units, you can, units, it's in meter. Function, it gives you in watt. Walla, watt. Patch has a watts per meter cubed. Watts per meter cubed. Okay. Well, argument goes from 0 to 1. Yeah, fine. Like if I say from 0 to 0.002, it will give me a problem. It's undefined here. If I plot this, well, this is the function from 0 to 0.1. Like if I say from 0 to 1, and I have see the plot. Okay, معناته هني from 0.01 هني 0.01 إلى 0.02, it's good. هذا الكونستنت function. 1 to the 5th. This will be beneficial بعدين. المهم هني when I go to the heat source, sorry I'm giving you يعني more than one idea to be implemented later. I think you can negotiate these ideas all at once. When I say my Q, it will be my Q constant, Adel. This is variable 1, my Q. I want to use AN1. So I go here to the general form and I'll say AN1. And it will complain. Why would it complain? لأن unknown variable AN1. It's not a variable. It's a function and it needs an argument as a function of x. It will not complain. Okay? ولكن if I say I go to the variable and I'll say this is ANX1, ما يصير. Okay? Function name, and this is the argument x. This is the function x مثلا x divided by x plus y times 0 times 90 times 0 minus 90 plus 90 plus. Okay, basically 1 to the 5th. I did nothing. But in a complicated function, I plot this, still constant. So this will take it from the analytical function. Right, that's it. شنو عندي بس boundary conditions و continuum heat generation. Oh, that's it. I can pair stuff together. I can have a line heat source and I can have a point source. I can add a global equation. Well, thermal conductivity is a function of temperature. What type of function of temperature? I don't know. Solve the problem and get the temperature and then get the thermal conductivity. So some complicated function of يعني طبعا هذا built in فيه you could add the thermal conductivity function in the material. لكن the heat flux is a function of temperature. What function of temperature? It's a bad example. Anyway, you need something built in, so solve it and then solve this additional equation. Okay. You could copy the boundary conditions one by one. You can disable it, you can enable it, you can rename, you can do settings, etc. واضح? Any questions? For the mesh,
The question watts per unit, which is correct, is kilowatts.
hey, kilowatt. So I need to 1 kilowatt هنيك. So E8 right. Mesh, if you the default mesh is unstructured, free, triangular, or pyramid elements in 3D, not quadrilateral, no brick elements. The defaults are triangular elements. So if I do this, it will mesh it. However, you have no options in here. If you want, you can control, the element size. So normal, this is coarse mesh, and this is extremely coarse, and 32 elements. Normal was 500 elements تقريبا, and you could do fine, extra fine to give you like 5,000 elements. You could also go to extremely fine. I don't recommend this unless you know what you're doing. 20,000 21,000 elements تشوفون انه ضعيفة, ولكن this is optimized for physics. Conduction, not a problem. If you had fluid flow, then it will look for the solid wall, and it will concentrate it will grade the mesh near the solid boundary, because it wants to catch the velocity profile really accurately near the walls to compute shear stresses and heat fluxes more accurately. So it will, by default, if you say physics control, it will concentrate the mesh around solid edges. Okay, but since they need conduction, it doesn't matter. Why? لا, it doesn't matter. It doesn't know الماتيريال. بالgeometry. This is internal. This is there's a wall here. It doesn't matter if it's a moving wall or whatever. المهم إنه في solid wall, interior wall. You'll see examples when we do fluid flow. It will know when solid boundaries, and it will concentrate the mesh there. Suppose you don't need this, you don't want this, you want user controlled, then it will give you a size node where you can say, and I want to optimize for general physics, extremely fine, normal, let's say, and it will give you the normal thing. Or you could do the custom for general physics again. You can specify the maximum element size, minimum element size, element growth rate, تكبر بسرعة, ولكن gradually this you control at 30% increase each time, and curvature factor to the shape of the elements, and the type of, or the resolution, the effort put into the resolution around the narrow regions like this corner. And it's free triangular. Mesh this using free triangular. Or I want mapped mesh. Oh, mapped mesh, applied when? Applied remaining? No, because I said this, for the free triangular I said remaining. Well, nothing is meshed, so everything is remaining. If I say entire geometry, it will do entire geometry. If I say domain by domain, I want just this one, the exterior domain. So I go to the mapped and I say remaining, it will do these the mapped way. Okay. However, it will do everything according to these settings. If I say predefined and I build everything, if I say predefined and I do finer, it will do this. If I do predefined and I do extremely fine, it will do this. Suppose I don't want this to be finer, so I add a size function inside this mapped mesh. Okay, let's delete this. I'll duplicate this size, another way of doing it, and I'll take this and I throw it inside this mapped mesh. So it applies only to its parent node. So this size is normal, and the rest are according to the default extra fine. So I hit this, it will do this.
Look, can't you make finer mesh only around the edges?
Yeah, I can.
The inner dome, the outer
I
inner
can.
dome.
ما أدري ليش ما يصير كذي, ولكن I'll do this. Oh, yep.
It's kind of reverse.
Yeah. So it can free triangular هني, because I said domain 1, or this thing remaining, not remaining, I need to specify هذه and do this.
Oh, okay.
Okay, so this is very coarse, extra coarse, and then extra coarse, and the one after it is extra fine. ليش extra fine؟ لأن الديفولت is extremely fine. You see? Do you see? Okay. In general, I'll go back to physics control or extremely whatever or normal, and it will give me this. If you go to user control again and go to the size, and instead of general physics you say, oh, I want to optimize this for fluid dynamics. I have a flow coming in, going out, a flow around this edge, your question, and do it normal distribution, and do it free triangular, remove the thing, or fine, and I build it. It didn't do it because there is no fluid flow physics. If I had flow physics and solid boundaries, it will do the boundary layer. Okay, so this, no matter what you do, it will give you the pure conduction type of thing. Anyway, so this is good enough, more than good enough for the mesh. Any questions? Once you do the homework, the 2-3 problems, the homework, you'll be fine. Stationary. Oh, another thing. Study 1 applies to study 1. Stationary time steps. What do you want to solve? I want to solve heat transfer in solids. This is the name of the physics, quote unquote. This is the name of the physics that you added. If I had more than one physics type, one type of physics, so I duplicate this. How can I duplicate this? I cannot duplicate this. I don't want to duplicate this. I'll just add a physics. I'll just add another heat transfer in solids. Okay? نفس الشيء بالضبط. So say all of these, and I'll copy them and I'll paste them. Paste multiple items. كلهم ياو هني. واضح؟ Either I solve this or I solve this. They are the same. Temperature هني, heat flux هني, هذا disabled, even the disabled. It gave me the disabled, and heat source اللي هني, analytical one, exactly the same. واضح؟ طبعا this solid 2 and solid 1, I don't need solid 1 or solid 2 لأن one of them was copied هني. Solid 2, I don't need the solid 2, I don't need the initial value, thermal insulation, everything is overridden. I don't need this, and I don't need initial value 2. I don't need initial value 2. Sometimes you do. Most of the time you don't need a second initial value. Okay.